All right, so the last lesson in this unit is about something called a percentile. And so you guys are probably used to hearing that, like maybe when you go to the doctor or when you get like test scores back, you'll see like, oh, you're in the 75th percentile for this, or the 60th percentile for this, etc. And so what a percentile is the number where a certain percentage falls below that number. So if you're in the 75th percentile, then that means that 75% of the data falls below that. So again, if you're in the 75th percentile for something, let's say a test score, then that means you scored higher than 75% of all the people who took that test. If, for example, like I just took my daughter to the doctor for her 2-year checkup back in March before everything shut down. And she is a tiny little peanut, and she is in, I think my doctor said like the 18th percentile. So she only weighs more than 18% of 2-year-olds. So she's on like the lower end. So for certain things you want to be on the lower end, for certain things you want to be on the higher end. But it all relates back to that normal distribution curve that we talked about yesterday. So I'm just going to kind of sketch this and walk through it again, how to break it apart. So if we've got our normal bell curve right here, the empirical rule states that our mean is right in the middle. So 50% of your data is above, 50% of your data is below. But then if you go 3 standard deviations above and 3 standard deviations below, there's our mean, plus 1 standard deviation, 2 standard deviation, and 3, and then we'll subtract going this way, minus 2 and minus 3 standard deviation. Certain percentages of your data fall within that, okay? And for percentiles, you want to break it into each like individual chunk, not the 68, 95, 99, 7. So we want to make sure we can calculate each individual percentage. All right, so if we go back to that 1 standard deviation, these aren't exactly even, but it's okay. So we said yesterday that 68% of your data falls within 1 standard deviation of the mean. And so that means that 34% would fall 1 above and 34% would fall 1 below. And then if we go out, 95% of your data falls within 2 standard deviations of the mean. But we already have 68% of that accounted for. So 95 minus 68 is 27. So that if we split that evenly between each one of these chunks, we get 13.5%. And then 99.7% of your data falls within 3 standard deviations of the mean. So 99.7 minus the 95 that we've already used is 4.7. So if we have to split that evenly between the 2 bars, that's 2.35% here and here. And then we've got 100 minus 99.7. So we've got 0.3%. That's either above or below 3 standard deviations from the mean. So if we cut that in half, that means everything left over is a super, super small percentage of your overall data. Okay. All right, so we are just now going to answer questions about those percentiles. We just, again, have to understand where to look on our normal distribution curve. So if I'm wanting to know where the median falls, where's the median value, what percentile is that in? Well, the median splits your data exactly in half. So that means that your median is going to be the 50th, oops, not 50%, the 50th percentile. So 50% of your data falls below the median. Okay, so this is going back into like to box and whisker plots. So the first quartile is in which percentile, the third, and then the maximum value. So again, the first quartile, remember, splits the lower half in half. So if we've got the median at the 50th percentile and we're cutting that in half, half of 50 is going to be the 25th percentile. So your first quartile value is going to be higher than 25% of your data. So the third quartile, so if you go 50 and then you split your upper half in half, that's going to be the 75th percentile. And then that maximum value, well, if that's the highest value, that means that that value is higher than every single other value. So that's going to be the 100th percentile. So this is whether your data is normally distributed or not when you're looking at the median. But if you go back to look at the mean and standard deviation, that has to be normally distributed. So your mean can't be adjusted either skewed left or skewed right. So if we know that our data is normally distributed, that mean value, again, is right in the middle. So that also is going to be in the 50th percentile. It's in the middle. All right, so now this is asking a value that is one standard deviation above the mean is in which percentile? So one standard deviation would be right here. So I want to know another way that question is asked, or could be kind of thought of, not asked, but is what percentage of data falls below this value? So again, we know that the mean cuts our data in half. So this is 50 plus 34 is 84. So that means that this is the 84th percentile. This, whatever value this is right here, it's bigger than 84% of your data. So this next one says a value that is one standard deviation below the mean is in what percentile? So again, if this represents 50%, 50 minus 34 is 16. So only 16% of your data falls below whatever that value is. So that would be the 16th percentile. Only 16% of your data falls below that value. Okay, so now let's practice making our own curve again. So this is the heights of adult women are normally distributed. The mean height is 65 inches. And the standard deviation is 3 inches. So 1, 2, 3. So that would be 68, 71, and 74. And then 1, 2, 3. So then this would be 52. Not 52, sorry, 62. 59 and 56. Okay, so if Mrs. On is 5 feet, 5 inches tall, what percentile is she in? And so first we have to figure out how many inches is that, since this is in terms of inches. So 5 times 12 is 60. 60 plus 65 is 65 inches. So I would need to figure out where 65 inches falls on here. Well, that's the mean, so that means that I am in the 50th percentile. So I'm very average for a woman my age. So this next one says if a woman is in the 16th percentile, what is her height? So I need to figure out where that 16th percentile is. And as you do more practice of these, you'll kind of remember how the percentiles relate to like how many standard deviations out you are. And you won't have to necessarily do this every time. But what you want to do is now figure out where that's going to be. Well, remember, if you're in the 16th percentile, that means that you're only taller than 16% of the people represented in your curve right here. So you're going to be down here somewhere. So I usually kind of start at 50 and then work your way back until you get to that 16th percentile. So we would say, all right, well, I know that that's 50. I know that that section represents 34% of your data. 50 minus 34 is 16. So this would be your 16th percentile. So that means that this person would be 62 inches tall. So this one now says if a woman is 71 inches tall, what percentile is she in? So if we know her height, now we're trying to figure out the percentile. We're kind of working backwards here. I need to figure out what percent this chunk is right here. Okay, so again, there's a couple ways to do that. I'm going to chunk it starting at 50. I know this is 34, and this is 13 and a half. So if I do 50 plus 34 plus 13 and a half, I get 97.5%. So someone who is 71 inches tall is taller than 97.5% of everyone represented in this curve. Typically though, with percentiles, you round down. So I would say she's in the 97th percentile, not the 98th. So you want to always round down. Even though technically we usually round up with 0.5 or above, you'll always round your percentiles down. Okay, and that is it for this unit. So again, your homework is posted on Canvas. Let me know if you need me.